Okay, my name is Richard. I'm here today to talk to you about CALayers. I'm going to start with a warning. There's quite a lot of visual content in this presentation. I'm a programmer, not an artist, not a designer. So I'm not very good at making pretty things. So brace yourself. It's going to get ugly. We'll start with the basics. What is a CALayer? The CA stands for Core Animation. In the UI kit, every single view uses a CALayer to get its contents onto the screen. That view's layer fills the bounds of the view and is responsible for holding and rendering what you can see on the screen. Every single thing on the screen in your iPhone app is there because it's in a layer. Even in your fancy new Swift UI apps, layers are used to put information on the screen. Which might seem confusing. Why would you have a view if everything is rendered with a layer? Or why would you have a layer if everything is rendered done by the view? I like to think of it as a separation of concerns thing. So views have to handle auto layout, subviews, user interaction. Why not let the actual pixels be under control of something else? So the rendered pixels of the layer are known as its contents, which is the actual thing that you can see on the screen. So my example here, in the middle of the screen, is a UI label, which is holding an important message. But it doesn't really jump out at you. So there are things you can do to any layer above and beyond setting the contents, and this may be where a lot of you have encountered layers before. First of all, you can set a border. This is configurable in its width and its colour. At the moment, it's a little bit boxy. So you can round the corners. You can set the radius of the rounding. You can set which corners can be rounded. Rounded corners are all over the place in iOS, and this is how you apply them. Sorry. And the last most common thing you might have done before with a layer is to add a drop shadow. This is a nice feature, but it doesn't play very well with rounded corners, because when you're rounding corners, you need to clip to the bounds of the layer, but the shadow extends outside the bounds of the layer, so you can't actually have rounded corners and a shadow on the same layer without it looking horrible. So to get around this, I've added a separate view, which is pinned to the size of the label, and the only thing that view is there for is so that its layer can render a shadow. But all of that is just using the layer that you get for free with any single view. Things start to get more interesting and a lot more fun when you add sub-layers to the layers. And there are tons of different CALayer subclasses. And we're going to move through some of those and see the kind of thing that you can make. But what it's possible to do using sub-layers is to compose together quite good effects from simple components. And composable is 2019's top program buzzword. So we're already winning. So in this section of the talk, I'm going to show you some silly things that I've made that should give you some insight into the sorts of things that you can make using layers. The idea I'd like to get across is that you can use layers for a lot of the graphical requirements in your apps. You're going to have more fun and have more flexibility using layers than you would using static images or doing custom drawing in a view subclass. So let's get started. Here we are in space. I don't know if you know this, but John Wilker, who organises this conference, also writes sci-fi books. Who am I kidding? Of course you know, he never stops talking about it. So when I applied to speak at 360 IDEV, I thought I'd increase my chances of getting accepted by doing a bit of sucking up. So I made this. I had to read all 4 books to get meaningful text to put into this, and you can't even read it. But luckily the books are quite good, so it's not all bad. And the sucking up worked, because here I am. Everything you can see in this video is made using CALayers. It's an old API. It's been part of iOS since the beginning, and it's been in macOS since 11, or OS 10 as it was back then. I think it's great, and hopefully you're going to think it's great by the end of this as well. So, how did I make this video? The star field is created using a CA emitter layer. That's one of my favourite layer classes, but it's quite frivolous and silly. I've been using it in quite a few of the demos today because I'm frivolous and silly. What happens is you give it a small circular image to represent the star, The emitter layer then takes that small image and spawns hundreds of copies with random variations in size, colour, position, and there's tons of other things you can change. Now these are static, but we're going to see moving emitter layers later on. The text is done using a CA text layer, which you can think of as a less powerful but layer level UI label. And then I have applied a CA transform 3D to rotate the text. CALayers are capable of rendering things in 3 dimensions. It's not exactly Unity, but if you've got some small in-app subtle 3D effects, you can get a long way by playing with your layers. And last of all, I applied an animation, since these are core animation methods, to move the text along the y-axis of the screen and the z-axis, since we're in 3 dimensions, away from you. Now the z-axis is a fairly new concept if you're not used to layers. So I'm going to talk a little bit about how to make things look properly 3D. So instead of the 2-dimensional transforms that you might be used to with a UI view, layers have a 3-dimensional transform. And if you're not a fan of 2-dimensional transforms, you're really going to hate 3-dimensional transforms, but you also may possibly be in the wrong talk. So it's a CA transform 3D as opposed to a CG affine transform, which is a 4x4 matrix as opposed to a 3x3 matrix. What that means, I don't know, I'm too handsome to do math. Or math. So the API for these is quite similar to the 2D transforms, though. So there's all the constructors for making translations or rotations or what have you, but they take a third parameter representing the z-axis, which goes into and out of the screen. On a layer itself, in addition to the position property, which represents its space, its position in 2D space, there is also a z position, which represents its position in 3D space. Even if you're not using 3D effects, you can still use the Z position to ensure that your layers render on top of each other properly, regardless of when you added them as sublayers. If you are using 3D effects, then things aren't actually going to look very 3D when you start. The Z position or movement in the Z axis only affects rendering on top of one another, unless you do this meaningless snippet of code. It's not very well documented, it's not very well understood. So what happens here is the host layer is what I'm referring to as the layer that's holding all the things that you want to have in 3D. All layers have a property called the sublayer transform, which is a CA transform 3D. And then N34, who knows, controls the perspectiveness of your layer. It's essentially the distance of your virtual camera from the layers that you care about, but then -1 divided by that distance. It tends to be a small negative number, but the actual right value to give you the effect that you want is going to change depending on the transforms you're using, the sizes of your layers, and so on. So here's a quick animation of moving the M34 value of the sublayer transform from 0.1, which is there, through to 0, which is there, and then -0.1, which is there. You can see that most of those values make everything look ridiculous, so you wouldn't do it. So it really is just a tiny little value that you want to change, but it does make a big difference. Staying in space and staying in 3D, I'm glad the projector managed to cope with that. There's a mysterious rectangle hanging in space. Ooh. It's actually a monolith, a precise 1:4:9 ratio. This is made of 6 CALayers, positioned and rotated in 3D space to form that cuboid. And then the layer that those layers are added to is being rotated about the X and Y axis to give the effect that you can see. I did try filling it with stars, but that was too hard. Now, admittedly, in your day-to-day app development work, no one's going to come up to you and say, "Hey, do you know what we need?" A rotating mysterious monolith in space. But it's more about showing you the capabilities of the framework. You can use them, for example, transitions can look quite good if you do some 3D stuff, or little opening and closing effects of menus. Okay, we might be bored of looking at stars, and I did promise you some moving CA emitter layers. So here's this. This is the candle with smoke coming out of it. The the two boxes with the same CALayers, and we have one emitter layer for the fire and one emitter layer for the smoke. Not very sci-fi, sticking with the sci-fi theme. My friend Ripley show up, and she gave me this very relaxing flamethrower. So how is all this working? The fire emitter has a single small image, and it's creating hundreds of copies of that image, and each one has got a slightly different velocity, a slightly different colour, a slightly different lifetime, and slightly different accelerations. And it's brighter in the centre of the flame because it can use additive rendering, so the more things you lay on top, the closer and closer it gets to white. It's supposed to stop, no panic. The smoke is using a similar thing in terms of its direction. It's a different particle. They're not additive rendering, and they go further up into the thing and they fade out rather. And the pilot light on the flamethrower is almost exactly the same as the candle, but it has a different base colour. And the flamethrower itself clearly just has a different emission angle, different acceleration parameters, and a different birth rate. The message here is that there are dozens and dozens of things that you can play around with in emitter layers. You can spend all day doing it. Indeed, you can spend most of your conference preparation time doing it. But it is a lot of fun. We tend to have a lot of iteration cycles to make them. So, this pixel-perfect reproduction of a scene from the film Star Wars, I did warn you, introduces two new layers. So the two suns are CA gradient layers. The sky is also a CA gradient layer. The suns are circular gradients, and the sky is a linear gradient, as it's dark at the top. Gradient layers allow you to specify any number of colours, the position of each colour within the gradient, the start and end point of the entire gradient. You can animate all those things. There are linear gradients, radial gradients, which you see here. And new in IS-12, there is now a conic or circular gradient. The blade of the lightsaber is made using my favourite CA layer subclass, which is a CA shape layer. The shape layer will take a CG path and draw it, which sounds quite boring, but you can put those things together and come up with some pretty cool stuff. You can specify the stroke colours, the fill colours, there are fill rules, there are line caps, line joins, lots of other things you might be familiar with if you've done any core graphics drawing. My favourite thing about CA shape layers is that you can give it one path, and then you can give it another path, and say, change to that path, and it will interpolate between the two. It will do all that work for you, and it can look pretty cool. So let's see an example of that. The thing on the right could be a hamburger button. We're all supposed to hate them, but they're everywhere. So why not make them a bit nicer? For example, if you tap the hamburger button to open your hamburger menu, wouldn't it be nice if it animated to a close button? This is done by interpolating between the two paths, and the layer does this work for you. It does the interpolation based on the elements of the path that exist. It can do the best job for you if there are similar numbers of elements between the two paths. So it tends to struggle if you're doing things like going from curves to straight lines, because it can't tell at which point the curve should become the straight line. And you can actually get quite a lot of control over the nature of the animation by being careful about how you construct the path. So here you can see the central element of the hamburger becomes one diagonal, and the top and bottom elements of the hamburger each become half a diagonal, which means we're maintaining the same number of path elements. So it gives a nicer effect. This is the final part of this section to talk, and I have precisely 2 minutes to waffle on until this fuse reaches the edge of the screen, which is quite exciting, isn't it? It took quite a bit of effort to render this video and put it into the presentation, so I did it, and I thought, well, I'm not going to change the video again if I can't think of enough stuff to say. So you might find me making artificial pauses, improvising, general waffle. Let's talk about what's actually happening in this screen. So the fuse is a CA shape layer with a big long wiggly path, and I'm animating the stroke start property of the layer. Stroke start, as you might guess, says where to start drawing the path. So it's going from 0 at the very start to 1 at the very end. You can also animate the stroke end. A lot of properties of CA layers that you animate are in unit space, so they'll go from 0 to 1. You don't have to know the length of the path or the size of the layer or things like that. The emitter, the fire at the end is another emitter layer. And what I'm animating there is the emitter position, which is a point-based property. And you can do things called keyframe animations, which allow you to animate any point-based property by supplying a path. And because I already had a path for the CA shape layer, I can reuse that path that has a flame where to go. If I was animating something else, like the position of a spaceship or a car, then you would actually see it rotate around the corners as it follows the path, which is a pretty nice effect. Wouldn't this be a better progress bar than the boring one you get in a normal app? And I've run out of things to say. So we could stand here in awkward silence, what you get at the bottom. You could guess what sort of layer I might have used for the final effect. Let's see what happens. Slightly underwhelming confetti cannon. That's another CA layer. You can see there's some spin variations on the particles and wide colour variations as well. Okay, that's enough fun. I'm going to talk about hard or confusing things to do with layers now, problems that I've encountered or problems that I know people run into quite often. Excuse me. The first one is layer masks. If I'm honest with you, I only really clicked in my head how layer masks work when I was writing this talk. So if you've never had the problem with them, then you've skipped straight to understanding. This is how I used to think they work. Don't pay any attention to this because it's wrong. Here's handsome Don Alejandro, just a regular Californian man going about his regular Californian business. Here is his mask. Some of you know where this is going. So the background of that mask is transparent, and the black area is opaque. So in my head, if that was the layer mask, you'd see all of Don Alejandro, except, it's Zorro! That makes sense, yeah? You've got a transparent mask, the transparent bits, the layer shows through, the opaque bits, the layer doesn't show through. Is that how it works? No. Definitely not. It's the other way around. So what happens is the mask, the alpha of the mask layer, becomes the alpha of the layer that you are masking. And I do realise that having a mask in my mask makes it hard for me to discuss about the mask that I'm using. So I have a more sensible example later on. So you need most of the mask to be opaque, and just the part covering his eyes to be transparent. But that's really hard to make, because you can't draw clear. You can only draw opaque. So if you're using a mask to try and hide parts of a layer, it can be quite tricky. You can get around it sometimes with a CA shape layer, in which case you would draw a path all around the edge of the mask, and then draw the things that you wanted to hide, and then use a different fill rule to make it fill in the outside bit. But that doesn't always work, and it really doesn't work if you're trying to animate the mask. So don't use masks to hide parts of your layer, use masks to show parts of your layer. Why are they called masks then? I don't know. So here's an example of using a mask to show parts of a layer. This is some lovely blue sky, and we want to have a rainbow on it. So here's a circular gradient layer. I've generated the rainbow colours by using the HSB initializer, hue, saturation and brightness of UI colour. If you step through the values from 0 to 1, that gives you all the colours of the rainbow. And you'll notice that the gradient doesn't start in the centre of the circle, it starts quite close to the edge, because I want the final effect to have like a rainbow shape on it. So all the rainbow colours are there is a rainbow in there, but there's a lot of non-rainbow stuff that we want to get rid of. And to do that, we're going to apply a mask to the layer. The mask is going to be a shape layer, and the shape is going to be a semicircular arc. I find it helpful when working with masks, not to add the mask directly, but to add it as a sublayer first, so that I can check that everything is in the right place. So here is the mask layer added as a sublayer. You can see the width of the line is about right, it's in the right position, everything looks good. So we apply that as a mask to the gradient layer, and we're just left with the rainbow part, which is what we care about. A lot of people find, if they start to do things with their layers, that it makes their app look or feel laggy. It's important to remember the A in CALayer stands for animation. So almost every property that you can set on a CALayer will be animated. Even if you just say corner radius equals 10, the update to that radius will be animated. This is called implicit animation. If you're changing things on your layers in response to user gestures, or while you're scrolling through a table view, you can be firing dozens or hundreds of animations off. Even if the calculation and rendering of those animations doesn't take up enough time to make you drop frames, it's still going to take approximately a quarter of a second for your update to that layer to be visible on the screen, which could be perceived as lag. So there are two ways to deal with this. The first one is every time you want to adjust something on your layer and you don't want that change to be animated, you have to wrap it in a transaction. So you start a transaction, you disable actions on the transaction, you change these things, then you commit the transaction. I think we can all agree that that's pretty horrible to have to do all the time. It's fine if you're only doing it in one place, but there's sometimes you never want implicit animation on your layers, and you've got layer updating code all over your app. It would be horrible to have to remember to do that everywhere. So there is a better way. First of all, I'm going to talk about how implicit animations work. So you make a change to the layer, and then the layer decides how or if it should animate that change. It's going to ask its delegate if it should animate the change. It's going to ask its actions dictionary if it should animate the change. It's going to ask its style dictionary if it should animate the change. I haven't mentioned any of those things before. That's fine, I've never used them, so don't worry about it. If none of those things come up with an animation, there's a class method on every layer which will return a default action, and that's where most implicit animations come from. It's typically a basic animation with a default timing curve and a 3-second duration. So what you want is not to have the layer do any of that work. Don't search for any animations. I never want an animation. And luckily you can do that by overriding a single method, which is action for key. So it's very easy to do. It's a very simple override, but you will need to do that for every CALayer subclass that you want to turn off animations for. So I will make a non-animating shape layer and a non-animating gradient layer. In the final part of the talk, I'd like to show you the actual work that I've been doing with CALayers. I'm using superpowered layers for high-frequency visualization of real-time engineering data feeds, which sounds good, doesn't it? It's got hundreds of thousands of data points. There are hundreds of layers rendering it. There's live data streaming in all the time, causing things to update. The user pinches and zooms to interact with 5 separate but linked visualization areas. There's gesture-based adjustment of calculation parameters, which trigger live re-rendering of the data, all in real time, 60 frames per second. Who wants to see that working? Yeah? Unfortunately, I'm not allowed to show you, for legal reasons. It looks a bit like that, but the pixels are slightly smaller. But it looks really, really cool. So it's a shame that I can't show it you, but I can talk about some of the lessons I learned while I was building it. It's a very complicated set of rendering that happened. So the first thing I had to do was to make sure that I was doing it properly, to make it look right. The data had to be accurately represented on the screen. Otherwise, the rest of the app is basically a waste of time. You could say this about any app. Getting it working is pretty important. And what's the easiest way to make sure you've got it working? You write the dumbest possible code that you can. I've talked about this sort of thing before. This is probably the key message of the talk, if not the conference. Humble brag. And it's not even about layers. If you're trying to do something complicated, you're going to get it wrong a lot, if you're anything like me. So don't make it harder on yourself by trying to save steps when you're midway through, or do something in a way that's harder to understand but seems maybe more efficient, or is a one-liner as opposed to 10 lines, or anything else like that. Get it looking right first. Don't make any assumptions about where heavy or slow parts of your code are at this point. Have it looking right. The fastest code in the world is pointless if it's producing the wrong output. So for the app I'm not allowed to tell you about, the dumbest possible code was to recalculate and re-render the entire data set every time. Made it super easy to work out where my problems were. And there were a lot of problems. But I did find, as I was getting towards the end of this, once it was looking good, it was running pretty poor, particularly on the iOS simulator. I've got quite a nice iMac at home. It's quite powerful, it's certainly more powerful than my iPad. It's running really slow on the simulator. Is everything terrible? Am I a terrible developer? Maybe, but not this. The simulator is pretty crappy when it comes to CALayers. I don't understand exactly why, because I don't work for Apple, but it's something to do with GPU. Layers use the GPU a lot. The simulator doesn't have a GPU, it has a software GPU, I'm led to understand. But the upshot of all that is that if you do anything fancy with your layers and it looks crap on the simulator, don't panic. You just run it on the device, so you can use the proper hardware. But there is another small catch. If you're doing a lot of stuff with a lot of data, debug mode is surprisingly crappy when it comes to doing stuff with arrays. So I've got all these hundreds of thousands of data points. I've got tons and tons of layers. When I'm creating my rendering and building everything up, I do a lot of stuff with arrays. Things are getting inserted, things are getting removed, arrays are getting emptied. And it turns out that in debug mode, that works really, really badly for some operations. The compiler is compiling for debuggability, which is a real word, and not performance. So it really, really affects the performance of your array operations, which means you need to run in optimized mode. So you ditch the simulator and you're building running on a device, you'll get better performance from your layers, but you're still not going to get a good reflection of real-world performance. The only real way to do it is properly with instruments. Instruments isn't very good at telling you that your layers aren't working very well. What it can do is tell you that the dumbest possible code you wrote isn't working very well. I have a lot of examples of this, which is fine there, because it can show it in your code. You can put the marker of shame on your lines that aren't doing very well. My worst one was the thing I was building up a huge array, because of the way I wanted it to turn out in the end, I was inserting elements at index 0, hundreds and hundreds and hundreds of times. It turned out, people that went to computer school will know this, I learned to program on the streets. It turns out that putting things in at index 0 is really bad. So what you do instead is put something on the end and then reverse the whole thing when you finish. And that works much better. But you've gone through your dumbest code, or your low-hanging fruit. Instruments is not giving you any peaks in the CPU usage. Performance still isn't very good. This really is your layers causing the problem. Unfortunately, there's no tooling to help you with this. You have to go back to caveman debugging. So the first thing I was doing is removing suspect layers. We either not add them in the first place, or not giving them any content, to see if I can find out which ones are causing the issue. And there are a few things in your layers that can cause performance issues that don't get mentioned anywhere by instruments. The first one is shadows, which we talked about earlier. If you just set a shadow on a layer, the way it works out how to do that shadow is by analysing the contents of the layer, looking for opacity, and then using that opacity, it decides where to draw the shadow. That can be quite a lot of work. If you know in advance where your shadow is going to be, if it is literally just a border around the edge, you can speed things up by setting a shadow path. And that will mean it doesn't have to analyse the contents of the layer, it can just draw the shadow using a path, which is much faster. Layers with shadows or other complicated layers can sometimes benefit from setting the should rasterize flag. Should rasterize tells the layer to create and cache a bitmap of the contents and draw that each time, instead of analysing the layer and the sublayer and re-rendering it every time. Sometimes that helps, sometimes that doesn't. There's a memory cost to doing it. There's a cost in the fact that it still has to generate this bitmap. If your layer contents change quite often, it usually doesn't help. It's one of those things you generally just have to set it, see if it makes a difference, and if it does, move on. The thing that affected me the most was, perhaps not surprisingly, path complexity. It seems that there is an upper limit on the number of points that you can render in a CA path layer, a CA shape layer, before it starts to just judder about and not be very good. But I needed my data on there. My data was the point of the app. So I had two approaches to reducing my path complexity. First of all, the situation where the user is zoomed right in to the app. In this case, because I'd written the dumbest possible code, I was still rendering the entire data set. Most of it was miles and miles and miles off screen. There's no real merit in doing that. So I added a clipping routine to only render the parts of the data that were on or close to the part the user was looking at. The other situation is when the user is zoomed all the way out, in which case you can't clip things because you need to see the full extent of the data. But if you've got 1,000 data points filling 10 screen points, there's no real merit to rendering every single part of it because they can't see it. So in this case, I added a filtering routine to limit the number of data points per screen point. And both of those approaches really, really speeded up the performance of the app, and the client was super happy, but not happy enough to let me talk about it. The other important thing that I learned when making the app was the importance of transforms. Transforms are so useful. They kept me completely sane while I was doing this. What do I mean? So, there are huge numbers of data points. Those points have at least 2 dimensions. At render time, you need to make data points into points on the screen. And then when the user is interacting with the app, you need to convert the locations the user is interacting with back into data coordinates. I call those two concepts data space, meaning the coordinate system of the data, and chart space, meaning the coordinate system that the user is dealing with on the screen. I've seen people handle the conversion between those two spaces by creating functions to convert each individual data point in their model and then mapping the model through it. There is an easier way using transforms. But before I go into that, I'm going to clarify the concepts of data space and chart space. So, this is data space. This represents the entirety of the model that your app is dealing with. As the owner of that, you know like the maximum possible range of values in each dimension. We know all of the values. This here is data space. The box represents the area of data space that the user is currently viewing. And these lines highlight on the axis there the visible ranges of that area in data space. And here is the device the user is viewing the data on. And you know the bounds of that area in screen points. We're now in chart space. So you have the following information: the maximum range of values permitted in either direction, the visible range of values in either direction, and the size of the viewport. And with that information, you can create an affine transform to move between data space and chart space. And you can invert that transform to move from chart space back to data space. What you can then do for rendering is create your paths in data space directly from your model, and then use CGPath copy with transform function to make a chart space path at the last minute. Let's look at that in a little bit more detail. So you start off with your data model. That can be in whatever format your app is currently dealing with. To draw that model on the screen, you will need to do at some point a kind of calculation or a map to get an array of CG points. These will still be in data space. For the calculations I've been doing in my app, this stage of the process has never been a performance bottleneck. I'm doing trigonometry, moving averages, all sorts of bits and bobs, and it always seems to work out just fine. So once you have your array of CG points in data space, you can use your chart to data transform to work out which of these points are going to be visible on the screen, or how many of them, and at this point you can do the filtering or clipping that we mentioned earlier. Once you have an array of CG points, you can make a path from that array using CG mutable paths add points function. Again, this one is incredibly fast. I've done this in response to user gestures with thousands and thousands of points in a path. It's never dropped a frame. It's super fast. So at that point, you have a CG path in data space. You then make a copy of that using your data to chart transform, which gives you a CG path in chart space. You assign that to this here shape-based path, and there it is on the screen. This approach means that you, up until the very last minute, you're still dealing with actual data values that you can compare against known things or API responses. And it only changes at the very last minute and makes your debugging process much easier. There is a word of warning about transforms and paths. It does not work for paths in real life. So on Friday, my colleague Joe and I decided it would be a great idea to take my sea level jet lag 14,000 feet up a mountain. It was hard, wasn't it? Yeah. But we were talking about transforms while we were doing this as a kind of way to numb the pain. I'm going to keep talking about transforms because they're so great. When the user is interacting with your app, panning and zooming, the data that they're viewing isn't changing. So there's no real need to re-render all of your past because your chart space might have moved around, but the data is still the same. You can re-render everything, but that is a lot of work, and if you're doing stuff in response to gestures, you need response on the screen. It needs too much work. What's more efficient is to generate another transform representing the operation done by the gesture. So a translation if they're panning, a translation of scale if they are zooming. You can then apply that transform to the layers that you are using to view, and then when it's finished, at that point you can re-render your data set. This is invisible to the user, but gives much better performance when they're interacting. The only slight side effect is that because you're applying a transform to the layer instead of to the contents of the layer, to the path, you will see that your lines in your paths will get thicker or smaller as they zoom. But a human hand is only this big, so the effect is not that pronounced. And then as soon as they lifted their hand off, you re-render, everything's perfect again. And that is all I have time for, or what I've written. 5 minutes to go, that's not bad. So, a quick recap of what we've covered. You know what a layer is, where they come from. There is loads of different types, they're all lots of fun. You can make some interesting things with layers. You can make some amazing things with layers. Well, you have to take my word for it, because I couldn't show you, but yeah, super good. It is possible that I overuse layers, because it's a tool that I've got, and it's a tool that I'm familiar with. You've heard the expression of all you have is a hammer, everything looks like a nail. But I think layers are a pretty amazing tool. So if all you have is a CA hammer layer, everything looks amazing. Thank you very much.